All right, now we're moving into the secant function. And when I evaluate the secant function on my calculator, I need to use a quotient identity and type it in as 1 over cosine of whatever angle that I'm working with. All right, so secant of 0 is equal to 1. Secant of 30 degrees, type that in as 1 over cosine of 30. That's going to give you approximately 1.155. Secant of 60 degrees is exactly 2. Secant of 90 degrees, you would be undefined. Asymptote right there. Secant of 120 degrees is negative 2. Secant of 150 degrees is negative 1.155. Secant of 180 degrees is negative 1. And let's reason out some further points using all students take calculus. Okay, so in quadrant 1, my points were positive above the x-axis. In quadrant 2, my points are negative below the x-axis. And then when I get into the third quadrant, secant is still negative, right? So at 210 degrees, I'll end up with negative 1.155. At 240 degrees, negative 2. And then at 270, another asymptote. Okay. When I get into the fourth quadrant, now secant becomes positive again. Okay. So secant of 300 degrees is going to be 2. Secant of 330 degrees is 1.155. And secant of 360 degrees is 1. And then we look over to the negative angle measures in the left here. Secant of negative 30, that's in the fourth quadrant, so we're positive still. Secant of negative 60, we're positive still. All right, so here's what the curves are doing. Actually, let me draw in. Need another asymptote here as well. So the points are behaving like this. They kind of look like parabolas, each of them. Okay, and let me trace this out on Desmos as well for you. Okay, so as I rotate in the positive direction, you start to see the secant curve sketched out. So that would be from 0 to 2 pi. And then here would be from 0 to negative 2 pi. There you go. All right. Now, the period of this function is often mistaken by looking at the graph. A lot of times students just focus on the asymptotes being 180 degrees apart, so they say the period's 180. However, understand that this piece of the graph is clearly different than this piece, right? The left piece is opening up, the right piece is opening down. So you can't say that those are repeats of one another, okay? So the piece that's opening up, it doesn't repeat again until you get over to here, right? So there's a total of 360 degrees before that happens. Period's 360. Domain's going to be based off the asymptotes. Our first one was at 90 degrees, and then 180 degrees later at 270. So I'll say x cannot equal 90 plus 180n, where n is an element of the integers. And then my range is based on the high and the low points of each of the curves. Would be from negative infinity to negative 1, union 1 to infinity. Okay. And here's an interesting property of the secant functions graph. Secant is the reciprocal of cosine, right? Well, let's graph the cosine function on this curve. See how it fits quite nicely in between this secant function. Okay. All right, cosecant function is going to look pretty similar. All right, so if I'm typing this in and evaluating on my calculator, I need to use the fact that cosecant is the same as 1 over sine, right? Cosecant of 0 degrees should be undefined. So right off the bat, asymptote. Cosecant of 30, type it in as 1 over sine of 30, and you should get exactly 2. Cosecant of 60, approximately 1.155. And then cosecant of 90 is 1. Okay, so notice all those points are above the x-axis. Then cosecant of 120, positive 1.155 again. Cosecant of 150, positive 2. So see, those are both above the x-axis as well. That's because cosecant yields positive values in quadrant 2. You'll end up with an undefined value at 180, so another asymptote. Okay, so we've covered first 2 quadrants. Now when you get into the third and the fourth quadrants, the cosecant function should be negative. So that means at 210 degrees, we should be, cosecant should equal negative 2. At 240, negative 1.155. At 270, we should be at negative 1. At 300, negative 1.155. And at 330, negative 2. And then our next asymptote at 360. Okay. If you go in the negative direction, at negative 30 degrees, cosecant should be negative 2. It should be negative 1.155 at negative 60, and it should be at 1 when x is at negative 90. Okay, putting that all together, my curves are doing this. Again, looks very similar to the secant function. We just have the asymptotes shifted. Okay. Period, once again, just like the secant functions, 360 degrees. Domain, your first asymptote occurred at the x or y-axis and then didn't occur again until 180 degrees. So any multiple of 180. And then your range, anything smaller than negative 1 or larger than positive 1. Okay. And cosecant is the reciprocal of sine, right? Notice if I graph the sine function here. Fits quite nicely within this cosecant function.